All right, almost done. On to the heat calcs. Okay, so first one here, we have 1,540 joules of energy were added to water, resulting in change of temperature of 15 degrees. What mass of water is used? So our heat formula, I always like to write it down before I rearrange the equation if we need to. We are solving for a mass, so if I rearrange my equation solving for mass, then C delta T needs to be divided out. So these cancel here. My new formula is mass equals Q over C delta T. The amount of joules of energy that were added were 1540 joules. My specific heat of water is 4.18 joules per gram degree Celsius. And they gave us the delta T itself. Sometimes they'll give you an initial and a final, but they actually gave it to us as 15 degrees. So 15 degrees C. And when we calculate this out, let's see what we get. We get around 24.6 grams. All right. For our last one, we've got a piece of metal at 92.4 degrees is added to 120 grams of water at 22.7 degrees C. After 5 minutes, the final temperature of the water was 30. Fill in the table, determine the specific heat of the metal. All right. So our metal has a mass of 73.5 grams. The initial temperature is 92.4 degrees. It was added to 120 grams of water. And the initial temperature was 22.7 degrees. And the final temperature of the water was 30 degrees. Something to remember is that when at equilibrium, the temperature of the water is the same as the temperature of the metal. So all that heat that the metal had, because it was at a higher temperature, was transferred into the water. And so then when the temperature of the water stopped changing, that means that the metal had released all of the heat that it had, and they become the same temperature. All right. First thing that we would do then to solve for the specific heat of the metal, we actually have to solve for the heat of the water, Q of the water. I can't solve for the specific heat because I don't know how much heat was released. So I would solve for the Q of the water. I'm going to take my mass of my water times the specific heat, 4.18 joules per gram degree Celsius. My final temperature minus the initial temperature. And when we do this here, we get around 3660 joules. And that's how much heat energy was absorbed by the water. Okay, so I'm going to go ahead and write that in, 3660 joules. We want to recognize that one of our main assumptions in this lab is that the heat that was absorbed by the water is going to be released by the metal. And we assume that those were equal but opposite in sign. So this is going to be negative 3660 joules. Now we have everything that we need to calculate the specific heat of the metal. So our last step then would be to take our heat equation, rearrange that for specific heat by dividing both sides by m delta T. So then my m and my delta T cancel. So my new heat equation then is C equals Q over m delta T. My heat released is negative 3660 joules. The mass of my metal was 73.5 grams. My T final, which is 30, minus the initial 92.4 degrees. And notice that the negative of the heat released is going to be canceled out by my negative change in temperature here. We should always get a positive specific heat value. And this ends up being around 0.798 joules per gram degree Celsius. That is our specific heat of our unknown metal. All right? Thanks for watching, everybody. Good luck on the exam.